Okay, today we're going to talk about exponential growth and decay without using logarithms. We'll figure out how to do the same problems using logarithms in the next unit. Okay, we start off with an accumulation function, and it's a equals p times the quantity 1 plus r divided by n to the exponent of nt. Now, these all stand for something. I like to call this print. It's an easy way to memorize it, but you still need to memorize it either way. The A stands for the accumulated funds, and then P is going to give you your principal. That's your initial amount that you're putting in. And then you get R, which is your rate, the interest rate, or your rate of decay, or your rate of growth, whatever the rate is. N is the number of times it's compounded. So how many times do you give it interest? And T is time. And usually that figure is in years, but with like bacterial growth or exponential decay, that can be in simply days or hours, depending upon what the substance is that we're starting with. So in this first example, let's say we start with $2,000, and we're going to put it in the bank, and we're going to get 6% interest. This is a really nice bank, evidently, since interest rates at this time are running around 1%. And we're going to compound it monthly. That's why we're dividing the interest rate by 12. So each month we'll get 1/12 of the 0.06%. And then we raise it to the power of 12 times 5. Now, what that's going to give us, we just plug that into our calculator, and we get an accumulated amount of $2,697.70. Now I've rounded it off to the nearest penny. This means that if we put $2,000 in a bank at 6% interest that is compounded monthly, that in 5 years we will have earned $2,697.70. Notice only the $697 is interest. The $2,000 comes from our original investment. So we'll earn $697.70. In the second example, we notice that instead of doing it, compounding it monthly, we're compounding it quarterly. Hence why we're dividing by 4 in the problem. Okay, and therefore we multiply by 4, which is the number of times compounded, times the number of years, which is 5, giving us an accumulated funds of $2,693.71. Notice this is different from earlier. Earlier we compounded it 12 times. This time we compounded it 4. So the more compounding, the more interest that the person will get. We got $2,693 in this one, and in the previous one we got $2,697.70. So just a few dollars more. However, if you're a bank, you would prefer to lend out $2,000 and make the extra money by compounding it monthly. So now let's look at our next one. Our next formula is continuous growth or decay. And that's where E comes in. E represents continuous growth or decay. If R is greater than 0, it's going to represent growth, and if R is less than 0, it will represent decay. We can see here in our next example, we take $2,000 and we're going to compound the interest continuously, the 0.06 interest times 5 years. That would give us $2,699.72. So since we're doing it continuously every minute of every day of every second, etc., we're going to get the most interest we can possibly get. Here's another example. Let's say we had 1,000 grams of some bacteria that are growing rapidly at a rate of 28%. So we have 0.28, and we're going to give it to a particular amount of time. let's call that time 10 years. So again, we have 1,000 grams of a bacteria. It's compounding continuously, that's why we're using E, at a rate of 28% for 10 years. This is going to give us 16,444.65, so let's round that off to 16,444 bacteria that will have developed in those 10 years' time. So we went from 1,000 to 16,000 over a 10-year period of time. This time we're going to do a decay problem. So we're going to have 10 grams of some substance that has a decay rate of 5%, hence negative 0.05. The negative is because it's decaying. And then we're going to do this for 3 years. When we get our result, we just plug it into the calculator, and we get 8.6, this is a decimal point, 8.607 grams. So the reason it's decaying so slowly, after the first half-life, it has a decay rate of 0.05%. And therefore it's decaying at 5% per year. So if you think about it, 5% is only 10% would be 1, 5% would be a half, and they're doing that for a year and a half. So we're going to get close to 8.5, or in this case 8.607 grams. Hope this was helpful. See you in class tomorrow. And when we do logs, the problem's going to be a little more difficult. But for now, let's concentrate on getting exponentials under our belt.